All right, so let's take this fitting and extend it out in New York City to see if that exponential trend changed. And we're simply going to do that by changing the graph because we have New York City going um, on down to well 5.4 yesterday. All right, but what is that? That's 66. So what we're going to do here is we're going to click on our, without having to do the redo the map, we're going to click on the series itself, not on the trend line, and you see this goes to 18. I want it to go to 66. So I'm going to change the 18s here to 66. Just that's what this means. Means it goes to F66, and there we go. And so that exponential doesn't fit very well anymore. All right, um, so I'm going to remove my trend line. See, it stopped fitting very well at about 30 days because things started slowing down, as they tend to do. So I'm going to right click and delete it, and we see this thing starts to come up and look like an S curve here. It starts to come up and then it starts to flatten out. So New York is flattening the curve. Most epidemics flatten out by themselves, so maybe what New York did worked and maybe it didn't. We're not really sure of that. But here we go. This is our curve, and once again we're going to right click and add a trend line, and we could go exponential, and again that's horrible. Linear, let's go put our squares on there. We're going to display our equation and our square. Well, now our linear fits pretty good. It would actually look pretty good if we change that to 20, but so now the linear fit is much better than the um, exponential. Um, we could look at a power function, and again, that doesn't work very well. Um, we could try a second order polynomial. We could go to a third order polynomial, and these are just different ways of fitting this curve. And so we can go to a third order where it's day squared, day cubed, etc. And then we get back to our really good statistical fit. Then we think we could take this third order fit and and project how far out this thing is going to go, and it will eventually turn down. And so we have another model that's tricking us into believing it's an excellent fit. It might continue to fit. It might not, but we see that it goes up and it goes negative, and there's some other things we'd really like it not to do. So there are a series of things called sigmoid or logistic functions that we use to try to fit these curving models, and we will get into those in a module from now. This is great to be able to show people data, but it's also kind of super important to show people maps, because once you start throwing equations up, you lose about 90% of your audience, if not more. But you yourself know, after throwing a couple of different equations and looking at how rapidly these things can change in just a couple of weeks, between what you think was a good fit and what is not a good fit for your curve fitting models, and we'll get into curve fitting a little more. But we've got the data. We were very quickly able to apply an exponential model, find out that it fit fairly well early on, get the entire country data, pull the New York City data out of that, and run some models. So we're pretty sure that this thing's still going to change on us. So if you're making fun of people who can't do the predictions, remember, we can only make the predictions based on the data we have. And what we were being told was it was the sort of thing that was direct human contact, stay 6 feet apart, etc. And then we found out it was pneumonic and could spread 75 feet and infect an entire plane and some other things like that. It should have been suspicious that that might have been the case given the rapid spread. But at the end of the day, it's a Wizzy-Yachty problem, right? What you see is all there is. You can make it up, and we'll talk about sometimes how making it up scenarios can be to some advantage. But I went down and I changed the names of all of my tabs, which is a really good idea, and I often don't do it. Like sheet 5 here. What is sheet 5? I'm going to call this exponential exact fit. because otherwise I end up having a bunch of tabs down here and I don't remember what they mean. Sheet 2 is blank. So I'm just going to delete that for a little bit of housekeeping here. Then I'm going to save and we're going to be done. All right, so that's the end of what we're going to do in the first exponential. We're going to move on to mapping. From here, you can move on to something else because this is modular.